Here we go. All right, so what's the next one say? Explain why at least 2 students at Cathedral must have the same first and last initial. Like I'm LF, so is Mrs. Finn. All right. How do I know, even if I didn't have a match, how would I know somebody at Cathedral had the match?
Because 26 and 26.
Exactly. For your initials, there's only, assuming you have everything, like X, Z, and every combination, there's only what? What is that? 26 times 26. What is that number? 676. There's only 676 first and last initial combinations that we can have, right? So if there's more than 676 people, doesn't that mean someone's going to match? Now, it doesn't mean somebody matches you. I don't know if anybody matches you or not, but there are people out there that have to match because there's only 676 possibilities. When I was a little kid, I would get so excited when I found out somebody had my birthday. I just thought that was the coolest thing in the world. But if you stop and think, it really isn't so cool, because there's billions of people in the world and there's only 365 days, right? So obviously, people are going to share birthdays. All right, now 26 and 27. These are key problems. I want you to read number 26, A and B, and I want you to tell me if they're the same question worded differently. These are all word problems, so we have to, interpret them. Are they the same question worded differently, or are they different questions? 26, A and B. Does anybody think they are different? We all think they're the same? Jacob?
Would B be after they chose?
What do you mean?
Like president, vice president, so that'd be instead of 20 times 19, 18 times 17?
Oh, no, I see what you're saying. No, these are, okay, so I walk in the room, okay, here's my group of people. How many are there supposed to be?
20.
20. All right, so let's say here's 20 people. I'm gonna walk in the room and I'm either gonna choose a president and a vice president, or I'm gonna walk in and choose 2 people to be like in charge.
Okay, that makes sense.
Okay, so I'm starting with the same 20. And I'm either choosing president, vice president, or I'm choosing 2 to be in charge. Same thing? Actually, it's not. I want you to think about this for a minute. Suppose I walk in and I pick Quinn to be president and Eli to be vice president. Okay? Is that different than picking Eli to be president and Quinn to be vice president? Yeah. I mean, it matters to you, right? Whether you're president or vice president, that's a difference. So question A is telling me that I am picking 20 people in order. Now, if I'm picking 2 people to be in charge, does it matter if I pick Sammy or Olivia first? If they're going to be the ones in charge, can I pick Sammy and then Olivia, or Olivia and then Sammy? Yeah, doesn't matter. If they have the same job in charge, then the order I choose them doesn't matter. But if they have different jobs, president, vice president, then the order I choose them matters. Okay? So 26A, order matters. 26B, no order. Mathematically, this is the difference between what we call a permutation problem and a combination problem. When you are choosing things and order matters, then it's a permutation. If you are choosing things and order doesn't matter, then it's a combination. If you are choosing for different jobs, then order matters, right? If they walk in and say, okay, the first teacher I pick is gonna teach English, and the second teacher I pick is gonna teach math, order matters, right? But if they just come in and say, hey, we need 2 teachers to go sit in the dining hall, doesn't matter. Both of these problems involve 20 people choosing 2. 20 people choosing 2. If order matters, it's a permutation, and I'll use a P. If order doesn't matter, it's a combination, and I'll choose C. I want you to go back to where you saw the factorial button. You remember where that was? Math, prob. What's right above that factorial symbol? NCR and NPR. That's how you're going to do these problems. So, for A, where order matter, hit 20. So, second quick, hit 20. Go into math, over to prob, and down to NPR. For the first problem, order matters. So, hit that button, type 2 and equals. Did you get 380? So the answer is 380. There are 20 people and you're choosing 2 of them in order. 20, math, prob, NPR, 2. Now, the second part is a combination. So hit 20, math, over to prob, down to NCR, because if I am picking for the same job, then the order doesn't matter. 2, and that's only 190. You have to put a 2 at the end. It's 20C2. Now, what about 27? Read A and B and tell me if one's a P and one's a C. For number 27, is one a P and one a C?
A is a C.
A's a C, she says. 13C4. Why is it a C? There's no jobs, no specific jobs, right? Just a group, just a group of people. But in B, same 13, still picking 4, but now I'm picking them in order. President, vice president, secretary. You see the difference, you guys? This is tough, you gotta be able to see that. All right, let's type them in on our calculator. What's the difference? 13 math, prob, NCR 4, 715. 13 math, prob, NPR 4, 17,160. Talks about a lot of big ideas today. Let's get that homework out. Let's get started on it anyhow. Anytime you answer one of these questions, guys, you need a number, okay? You need an actual number. So the setup, for example, might be 13C4, but the answer is going to be 715, all right? The number is the answer. All right, so let's look at number 1. How many ways can 7 seniors be lined up in a row? 7 factorial is your setup. And then I think I remember that's 5,040.
Yeah.
How many ways can first, second, and third place trophies be awarded to a group of 6 people? You can do this 2 different ways. What clicks in your mind?
125 times 4.
6 times 5 times 4? That'll work. Anybody think of anything else? How about 6P3? Am I picking them in order? So 6P3 will give you exactly the same answer. So if you'd rather do 6 times 5 times 4, that's fine. That will work on permutation problems. That'll work on these. It will not work on these. These you have to use your C button. But if order matters, you can do 6 times 5 times 4. So what is that, 120?
Yeah.
How many 4-letter words can be formed from TRUI? Are there any duplications? So it's just 4 factorial. 24. How about Ella?
4 factorial divided by 2 factorial.
4 factorial divided by 2 factorial, because there's 2 L's, which is what, 12? Special cathedral license plates, 2 letters followed by 3 digits. How many, oh, this was a problem in the notes. How many are possible if there's no restrictions? 26, 26, 10, 10, 10. You with me? That's A. No restrictions on letters or numbers. How about if nothing can repeat? 26, 25, 10, 9, 8. Guys, are you following along? Everybody keeping up okay? Only odd digits can be used, but there are no restrictions. So letter, letter, number, 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 but I have to be odd. So how many letters?
26.
26 and
26.
26, right? No restrictions. But I have to use odd numbers. Okay, how many odd
5.
digits are there?
5, 5, 5.
5, 5, 5. Odd digits. Multiply them all together. Last one. Fastest homework ever. How many ways can a president and a treasurer be chosen from a group of 19 people? 19P2?
Yep. 342.
What'd you say?
342.
342? Everybody okay with that? All right, if you're here today, you don't need to turn that in. I'll just give you credit for it.